All right. So, how can we make computer using agent possible? So, there are three aspects that we need to take into account: architecture, data, and adoption. Right. So, right now we have this LLM architectures, which is based on transformers. However, this is actually very limited. When we want to do grounding, grounding is best with relative position coordinates. However, it's with LLM, then it's all absolute, right? I mean, it's just like outputting something. And also, so that has to be modified in terms of the training data, but also in terms of the architecture itself. And the number two is also the button in the computer desktop is actually very small. When we really look at stop sharing, or when we really look at this kind of button, for instance, it is actually very small in comparison to the whole entire screen. So a lot of architectures will actually struggle with that. That means that we have to make it hierarchical in the way that which one to focus on, and then after that, detect and classify, or even to know which button to click. Because based on our research, uh, that particularly in terms of the buttons clicking coordinates is extremely terrible. It's going to try to click here, but eventually it landed here. So that's the current approach that we not
Yeah.
for, yeah, for Quen, and also for O3 and ChatGPT GPT 4.1. All right. Any questions so far? So this is about architect.
So
Yeah.
yeah, like one question would be how can we solve this attempt, this kind of problem actually? Any ideas or like
Yeah. So the number one is that, as mentioned before, the button can be small, right? So this is actually a huge problem.
yeah,
And we have to probably, I forgot to mention about this. There are a lot of ways to solve computer using agent. But eventually, we want to get to pixel level, which means that given a specific screenshot, given basically a display, then the AI is able to see what it can do, what is the next step of the interaction with the desktop. This is much like how we basically use a computer, right? So we see the screen, and then we
yeah,
see, there's like a little button here. Let's click on that in order to do according to our intention. But there's also MCP, and MCP is further far easier because MCP is accessing it much like talking via code, talking via an API. So there's MCP Blender, for instance. There's also MCP Godot, and a lot of other MCP, which basically means that it's gonna inject it directly to the architecture or the systems of Godot or the system of Blender. In this case, then the agent does not have to see the pixel level anymore. It doesn't not have to see the desktop. So right now, this one, which is code level, is the one that is extremely possible, but the pixel level have is where we have to go because it introduces flexibility in the way what kind of app we can use and all, right? There are a lot of apps that does not have MCP yet or even to the future. So this pixel level in the way how human being basically operates, uh, uh, agents have also to be integrated. So for the pixel level, the hierarchical is actually the solution to the problem. Not only that it just see the whole screen, but it's going to first, okay, which part of the screen I have to pay attention to, right? So we just want to reduce the effort that the AI have to do. If we reduce the effort that the AI have to do, then principally, then it will be easier for the AI to detect something, which also improve accuracy, right? So, for example, if
yeah,
it should supposed to click on this button, then first of all, okay, which part of the screen we have to pay attention to? All right, so this is the part. Okay, make a screenshot on this part only, zoom in, and then pick from all of this thing in the screenshot, which one should I actually click? So that's actually how we can improve COA or computer using agent from pixel level. But the MCP is something that we can already try, and I think right now looking at codecs, looking at different kind of architectures, open source also like Quen, DeepSeek, uh, understanding MCP, how to use it, is actually something that is already really well. Like it can do uh, such a good job on it. Is that clear?
So
Mm-hmm.
so MCP is basically like a help for the AI, like in a way of an instructor, kind of, or
Not really. It's more like a tool. So when it's
a
like a
tool.
tool, but the funniest thing is sort of like a tool connected directly to the brain, right? So in the case of the
Hmm.
robot, the MCP will be the arm, right? So if I want to use the arm, or the AI wants to use the arm, then the AI will just call the MCP. So previously it already knows, hey, I have this tool that I can access, and then it just simply access it accordingly. It's like calling a function,
Oh,
you know?
that's really,
Exactly.
yeah,
And the good thing about MCP, it's much more directed. So for example, in order to build a model on Blender, there are a lot of way to go. So you can just drag and drop, right? On a Blender,
yeah,
on Blender. So drag and drop, Shift A, add meshes and stuff like that. So that's how we normally do things on Blender. But on the other hand, can you do it programmatically? Totally possible. So on Blender does allow you to build mesh programmatically, right? So if you want to make a box, then you can also program a script which you can run on Blender. Then that script will basically add a block of mesh in the Blender. So MCP is basically, in terms of computer using agent, is basically writing the code and executing directly in the Blender. So that's more
oh,
like
that's
what
really
MCP is.
nice.
Exactly. So in terms of the current status of agent, the current state of the art, that is much easier for the agent to do because we currently a lot of people now code using coding agent, right? So that is
Yeah,
much better already, right? On the other hand, if we really look into um, Blender, that's just like click, click, click. AI right now at the moment, any kind of AI still cannot do that well since it's much more difficult
mm,
and also data is not available, which will come to our topic with data, right? So
yeah,
architecture can go only so far without data, right? So data is very important. As I said previously, that the desktop or the screenshot is the data that we have to input in order for us to achieve the pixel level or in order for us to achieve human level, right? Right now, the closest that we can have is tutorial videos on YouTube. Right? Tutorial videos on YouTube or tutorial videos that have been recorded uh, locally and you have to pay for it for an educational purpose. But it's basically all of these are data, right? How to use Blender and you can basically parse it. So the step one is to parse all of these videos and make it as data ingestible, understandable by the AI agent that's going to access the computer. Then that's data, right? The number two is actually coming from the user of the computer using agent tool itself. So the all of the screens, it all can be recorded. It all can be logged, right? So okay, first we click on this one, and then second we click on that one. So this can be recorded, and this kind of data is not available for us on the internet, right? Because internet is about text and images and videos, but really intent specific click and then click and then click to that degree is not quite available. The closest we can get is tutorial videos. So this kind of data
yeah,
we can get from the actual user of our computer using agent tool, right? So if we make it open source, then we also have more trust in the way we can collect this data, not for our benefit, but to actually develop the tool kind of benefit, and not even for the company's benefit, but it's also for the entire community's benefit because we have it open source. But long story short, the data is extremely important to have that. Finally speaking, maybe this relates to the architecture. Human being actually does not require a lot of data. It's funny, right? Because when we try to learn Blender, yeah, we will do mistakes, we'll try again, we try again, we try again, but we do not have like 100,000 recording in order to learn a specific thing, right? So at the current moment, the architecture that we have with transformers, and basically transformers end to end. Okay, there's no modification, just like plain transformer architecture. Is that we require a bunch of data in order for the AI to learn a specific intent. If, for example, Blender, please build a house, like a house model. That requires a lot of data. However, human being, I do not think anyone in the world have like 10,000 tutors. Mainly like maybe two, three tutors, and then the rest is like trial and error. And from there, we can actually gain experience, right? So it's very data efficient, actually, a human being. So that thing,
Yeah.
in terms of architectures, we can modify it accordingly, right? How does human actually have this efficiently? So one way is to also include reinforcement learning, and then the second one is also to simplify the problem. So instead of, hey, look at the whole screen and please determine the exact pixel that I have to click. Instead of that, we can first attend, or we can first filter out from the whole screen which one we do not need, and after that we can actually see the relative position from an architecture specific to just selecting button, right? So that's the way how we can actually improve a combination between architecture and data. But in the end of the day, the more data that we have, in order of millions or even billions, then we have a better AI. Right? Is that clear about the data?
Yeah, totally. Like it's very interesting and yeah, I'm really looking forward into it.
Awesome. And then last but not least is adoption here, right? So adoption is important. So now we have the way how to build a COA agent, but this is just the brain, right? The adoption, the way we can think about it's like, how do we normally tell people to do something on a laptop, right? So right now, a person is using a laptop in order to execute a certain mission, a certain goal. For example, I want to make a game. Then I will open Unity or Godot, and then after that, I make a game, and then we export the game, and voila, right? We got the game. But all of these are basically uh, operated by a human being, right? So that's the data and architecture. So that's already everything. But it's also very important to know how we can actually let people to use the tool, the computer using agent tool. And very simple as a solution is that in the way that we just speak, what is our intention, and we can see and we can review, or we don't have to review, then it can just go, or we just see what actually the AI agent is doing, and after that accept. So the adoption happens with a clear understanding of the people, how I can actually use this, and it will be easier. Okay, the way you use this is the same way how you talk to other people. You can interrupt at one point, right? You can also record in the way that this part, please do it for the rest of the thing. Then that thing can actually be converted to an automation, right? Which is a repeatable action, right? So those kind of things are not actually part of the brain, but more part of the features and the nicer thing in order for this tool to be actually usable by a wider audience. So a lot of startups these days actually do not handle the data and architectures. So this is normally built by a bigger company like OpenAI or Quen, like research company, or Grok. Most of the startups actually do this, right? So how to use the API given by OpenAI, and then we can build a tool around it that is so easy for the people to use, right? But in order to get computer using agent, until now what I see people are doing is actually focusing in this, right? However, the current LLM is not yet sufficient enough to actually do different kind of computer using goals and missions. So all of the trees have to go hand in hand in order for the computer using agents to actually prosper. And the funniest thing about computer using agent is the same thing, the same problem why robotics is much slower than, for example, a chatbot these days, right? We have Lovable, for example, which is coding agent with bunch of coding agent, but then a lot of startups of robotics that actually already started 2 years ago still haven't figured out, how to actually make the robot as well as possible. They will use OpenAI API. They will use different kind of LLM, but they are all limited because they have to train their own data in architecture, right? So this is a similar
Yeah.
problem also with computer using agent actually. The architectures of the agent have to be as simple as possible. Again, remember that we cannot build a brain, but maybe we can modify it in order for it to accomplish a certain task, right? So it's the architecture of the brain itself that we can modify, and then the data in which we can somehow collect, right? And these data are not internet data anymore, but the data that's more specific is like our action, our movement, clicks and mouse clicks in the way that a video simply cannot capture. And then the third of all is the adoption in the way how we can actually make the tool after building everything. How we can actually make the tool as easy as possible for people to use, right? That it feels natural, it feels simple, it feels like I'm just telling someone else to do a certain task, right? So
Yeah.
those three things combined, then we have computer using agent, and this is, I think, the journey of building a computer using agents until the end. Is there any comment or
Wow.
question?
Like,
Yeah,
not certainly a question, but it's like very, very like, how should I say?
yeah.
Like amazing. Like
Wow.
really amazing.
All right. So there are a lot of work here. It's definitely a difficult problem, but
Yeah, totally.
we do believe that this is the one that's going to make the biggest impact, right? All of the SaaS right now, for example, chatbot and stuff like that, chatbot can basically be replaced by a computer using agent because right now we have WhatsApp, right? If an agent can already handle WhatsApp really well and also handle Blender really well, then you know, um, yeah, the extent of what we're building here is pretty far, and let's do it. And also throughout this video, mhm.
Mm-hmm.
Okay, that's it actually. I think I'll just cut the one in the back. Okay.
Okay.
Thank you for watching and stay tuned.
Stay tuned.